Right. Okay. So today is mostly the anatomy of the ear. So we'll look at all the different little structures in the ear. And then Wednesday's class, we'll talk more about what they do actually in the physiology there. So yeah, so we'll start with the external ear. The auricle or the pinna is just the external part, right? The part that we can see of the ear. Um, it does actually act as like a little bit of a funnel, right? It actually collects the sound for us. And because of the touch receptors in the ear, it can tell us what direction the sound is coming from, right? And that can kind of help us to know what direction or where the sound is coming from that we're hearing. Um, Other animals can use this part of their ear a lot better than us, right? You guys know what I'm talking about, dogs and cats. When you're behind them, they can turn their ear around and listen to you, right? And they still face this way, right? We can't quite do that. But yeah, I think a cat has something like 15 different muscles that it uses to control its ear or something. We don't have that, but pretty cool, right? They can actually move and collect sound in different directions at the same time. And then we get down into the canal itself, right? It's called the external auditory meatus, right? That takes us to the middle ear, has specialized sweat glands called ceruminous glands, which make earwax. Right? Earwax is good for trapping things and repelling insects, and just helps to keep things out of our ear. Okay. All right, so then when we get to the eardrum next, the tympanic membrane, and then past that is the tympanic cavity, which is the middle ear. Okay, so this is again an air-filled space. So obviously the canal on the external ear is air-filled. The middle ear is also air-filled, but this is lined by a mucous membrane, and the boundary between the eardrum and the oval window, that's what makes up the middle ear. Okay, we'll talk about the oval window here in a sec. But the eardrum, or what's also known as the tympanic membrane, is the start of it, and then the oval window is the other side of it. Okay. The tympanic membrane is a kind of flattened slash cone shaped structure that points medially. Okay, so points this way, the little cone is pointing in. Okay, it's actually just skin on the outside, right? That's what you can see when you look into your ear, into somebody's ear with an otoscope. But then it's this mucous membrane on the inside. So its job is to transmit sound from the external ear to the middle ear. And sound is traveling through air in the external ear, right? And then it vibrates that membrane, moves it back and forth, just like a speaker, really, right? If you've seen a speaker working without the cover on it, it has a big membrane, right? It has like a big flat thing that goes back and forth, right? That's exactly what the tympanic membrane does, right? It's moving back and forth just like a speaker. Where a speaker then vibrates the air. It's kind of doing the opposite, right? We're putting electricity into that speaker and then that makes the membrane move. This is kind of the opposite. We're vibrating the air first to move that membrane, and then that membrane then vibrates the bones that are attached to it, right? And so that's kind of the idea is we're taking that sound from being in the air to then being a mechanical movement by moving that membrane and then moving the little bones. And so the little bones that are called the auditory ossicles. These are by far the smallest bones in the body. This is a nice picture just to kind of put it into perspective of how small they are compared to someone's fingers, right? They're just these tiny little bones, but very delicately and specifically and intricately shaped, right? When we zoom in on them, you can see they have these special little shapes to them, which the one looks like a hammer, one looks like an anvil, and one looks like a stirrup, right? And so the function of these is to transmit the sound from the middle ear, then into the inner ear. Okay, and one interesting thing that can happen is when we get a very loud sound that comes into our ears, we actually have muscles that attach to these bones. Okay, um, and and there's actually little synovial joints between these bones. You can see a little hyaline cartilage in there between the two. So these tiny little joints, right? They're literally the size of like the tip of your pencil, right? Would be like the size of the synovial joint. It's got a membrane and everything, but then there's muscles attached to all of these. And so when those muscles contract, they kind of stiffen up the joints so the bones can't move as much. And that makes it so we don't transmit as much sound, right? The less those bones are moving, the less sound gets transmitted into the middle ear. I was on top of the tables trying to get the projector a little bit higher before you guys came in, but I couldn't do it. So I'll have to put in a work order for that. But maybe that'll help a little bit. We've got a little bit of space up there, but we'll try. Sorry about that. Yeah. Hey, Melissa. Read the last. Yeah, sure. It just says tiny muscles tighten joints between ossicles and limit vibrations. Yeah, good. So yeah, why don't we open that up on the clicker there just to check there. Go ahead and hold on one sec. Yeah, so which bone touches the eardrum? Talk about the order with your team and send in the one that touches the eardrum or the tympanic membrane. Now you should build it up. But they're what? Ring? Yeah. Yeah, we'll talk about it, but once we get to the cochlea, it'll make more sense. But there's like, yeah. If I don't answer it when we get to the cochlea, then you can ask it again. Yeah. All right, go ahead and send that in. Nobody came for this. All right. Anybody else? Got 43. So 2/3 of you put A, and then about a third of you put C. Okay, so some are saying the malleus, some are saying the stapes. So the order goes the malleus first, that's the one that's touching the eardrum. Okay, the incus is in the middle, and then the stapes is closest to the oval window. So it really goes in this order here. Okay. All right, questions about that at all? Okay. All right. So another aspect of the middle ear is what's called the pharyngotympanic tube. Okay. Sorry about that. You guys are this classroom is gonna make me restructure all my slides, not have anything uncover on the bottom of the slide. Hopefully that one's not too low. But this is what we used to call the eustachian tube, but there is just really this canal in your cranial bones that connects the middle ear to your throat, right? And that's what the pharyngotympanic tube is. So the pharynx is your throat, right? And then the tympanic cavity is your middle ear. So it's just that pharyngotympanic tube. Okay. This is if we're just sitting there at rest, then in the part where it connects to the throat, it gets kind of closed off. Okay. But then when we open our mouth, either by yawning or swallowing or chewing, that just kind of kicks that little canal open. And the whole point of this is to be able to equalize the pressure between the middle ear and the external ear. Okay, because the external ear is always open to whatever pressure we have outside of it. But you guys have all experienced this when you drive up to the mountains or come back down from the mountains. Driving up to the mountains, the atmospheric pressure is lower in the mountains, right? The higher up we get in altitude, it's lower. And so what that means is the pressure in your external ear has dropped. But if you didn't open up that pharyngotympanic tube, then you still have the air in your middle ear that you did when you were down here. So it's higher pressure, right? So that makes your eardrum pop out, right? It pushes out, right? Because there's higher pressure inside than there is outside. So your eardrum kind of just pushes out a little bit. And that's the kind of that uncomfortable feeling that we feel when we have that pressure difference. And so this is the worst when you have a cold or something, right? Because you can't open your pharyngotympanic tube if you have mucus in there. And so then it just kind of stays that way. And just, yeah, kind of stuck with that uncomfortable feeling. Questions about that? Okay. All right. And then we get to the third spot here, which is the internal ear. Okay, so this is a very, very delicate membranous structure, completely just embedded in bone. Okay, it's all fluid filled now, right? So external ear and middle ear were air filled, but the internal ear is all fluid filled now. Okay, and there's three specific regions here. So the semicircular canals are three looped canals. They help us with awareness of rotational movement of our head. Okay, so three looped canals, really kind of trying to cover all three dimensions of movement, right? Okay, those are the semicircular canals. Then we get to the vestibule. The vestibule is this little egg-shaped thing closest to the oval window, and it functions in two ways. It tells us the position that our head is in. That's just like static position. Are you upright? Is your face down? Is your head back? That's giving that information. And then secondly, linear movements of your head. So moving forward, moving backwards, moving side to side, not rotational, but those linear movements. And then finally, the cochlea is hearing, right? This is where all of our hearing sensation is received and then sent up to the brain. Okay, and you guys remember the name and number of the cranial nerve that connects to all of this stuff, right? What number is it? Anybody? It's 8. There we go. Yeah. What's that one called? Vestibulocochlear nerve. Yep, there we go. And so part of it goes to the vestibule, part of it goes to the cochlea. It actually like kind of splits into two. The part that goes to the vestibule also goes to the semicircular canals. And so it's cranial nerve 8. So that bottom thing that uncovered just says the name and number of the nerve. Cranial nerve 8, vestibulocochlear. The next slide is a labeling of all these structures. So I'll leave this up for a sec so you can finish writing it down, but you can go ahead and start labeling on that next slide when you're ready. All right, and you're going to send in the number. There's a little question on the bottom there. This says send in the number of the structure that gives awareness of rotational movements. So you'll send that in, but go ahead and fill in all of this, label all of this, and send that one in on your clickers. Did you want those little food earring things?
Oh, that was from Greece, but he's not.
No, like right here. I'll bring it back.
Apparently,
Yeah. Yeah.
Your hands. Oh my gosh. I'm like,
So write all this stuff in. Don't wait for it to uncover. Write it all in.
Wait, why does it say one?
So just start scrolling, and you get all the other numbers. Yeah, and then
Oh.
just hit send when you're ready. Yeah.
Oh, okay, thank you.
Yeah.
Oh.
All right, go ahead and send that in if you haven't yet. You'll need to hit the send button, most likely. with This type of question. All right, go ahead and send it in if you haven't. You got 42 of you. Most of you are saying 9 there for the answer. Let's walk through this together here. Okay, so A, B, and C are just the bigger regions. And so obviously A is the external ear, right? B is the middle ear, and C is the internal ear. Okay, let's walk through these structures here. So one is the, yeah, we'll get those first, and then one is the auricle or the pinna, right? Two is just that canal or that meatus, external auditory meatus. Okay. Three is the tympanic membrane. You can see that cone shape much better there. You can see the tip of the cone connects to the malleus there, that little bone. Okay. And then we've got number 4 being the pharyngotympanic tube, a connection between the throat and the ear, middle ear. Okay. And then 5, we got the oval window. So the oval window is the start of the internal ear and where those bones are going to vibrate on there to then vibrate the fluid inside of the internal ear. All right, then we got the 3 bones, the malleus, the incus, and the stapes. Okay. And then number 9 is what most of you said for the answer to this question, which is right, which is the semicircular canals. Okay, 10 is just kind of the base of that, right by the oval window. That's the vestibule. Okay, and then it splits up the nerve into 2 branches here. All right. So 11 is the vestibular nerve, and then 12 would be the cochlear nerve, right? But we know it as the vestibulocochlear nerve. And then finally, 13 is the cochlea, part that does the receiving of sound. Okay. All right, questions about any of those structures? And so I definitely highly encourage you to utilize these notes in the way that they're designed, which would be to fill them in, and to write your answers in them before you see them come up. A big thing that is shown in the research, and is one reason why I use clickers for classes, is because making a decision on something, whether it's right or wrong, helps you learn it. And so that's part of like using the clickers is you got to decide on the answer to the question. Same thing with filling this stuff in. Most of you have some way to cross it out or something, even if it's not the perfect answer, right? But making that decision and then having to fix it or not, being confirmed that you had the right answer, is actually really helpful for your learning and for your understanding. So I encourage you to do that and not wait for me to uncover them. So, okay, questions on any of this? All right, so let's talk just briefly about this pathology of middle ear infections. How many people have had an ear infection like this before? Like when you get a cold and then it turns into an ear infection. Anybody have the whole thing where you have to get like the tube put in your ear and stuff like that when you're a kid? Anybody deal with that? No, nobody? Yeah, it's somewhat common. But yeah, this is also known as otitis media and some kind of infection in your middle ear, right? Your middle ear is supposed to be air filled, but when we get an infection of that mucous membrane on the inside, then it becomes fluid filled, and that whole part just fills with fluid. And that makes the bones very sluggish in the way that they move, right? Because now they're kind of moving through this like thick, pussy liquid, right? Instead of air. And so it makes your hearing very bad, right? It makes everything sound like you're kind of like underwater almost, right? Um, and so this is much more common in kids because they have a much shorter tube, and especially in babies because they lay down a lot. And so that's easier for bacteria and viruses to get up in your middle ear. And yeah, and so it can definitely have some complications there, but antibiotics are the most common thing here. If you get a bunch of them, then they put a little tube in there like that kind of helps relieve the pressure that can be created in there. These can be really painful. And your eardrum can burst actually too. If you get so much pressure in there that it just bursts your eardrum, and can be super painful. So, okay, questions on any of those? Okay, so we're going to talk in more detail about the three different structures inside the internal ear. But what we find inside of all three of those structures is one common receptor, which is the hair cell. Okay, so these little cells that are connected to neurons at the bottom, right? So we can see the neurons connected there at the bottom. And then the top, they have these cilia called stereocilia on the top. Okay, and those stereocilia, depending on which structure we're talking about, are embedded in something. And then that something is going to move in some way, whether it's moving based on sound that comes in or moving based on the movement of your head. Um, but yeah, so and then they're all supported by cells, all connected to cranial nerve 8, right? And so this is a version of a mechanoreceptor, right? Some kind of mechanical stimulus moves these hair cells that activates them to send an action potential into those neurons, and that goes up to the brain to be interpreted. Okay, so let's talk about the cochlea first. The cochlea has three little canals in it, and they're all wound up in like this the shape of a snail, and that's what cochlea means, is snail. Okay, so the upper canal is going to be the one that receives the sound. Okay, and it receives it from the oval window, right? So that oval window is again connected to that last auditory ossicle, and when it moves, it's moving around that little oval window. Okay, and this is a version of amplification of the sound because we went from the bigger tympanic membrane, which is like 3 times the size of the oval window. And so there was a lot more area to move. And then all that's kind of focused down onto this little tiny oval window. And so in a way that amplifies the sound, right? Um, and so, yes, we're moving that little window, and then that vibrates the fluid inside this upper canal. Okay, and then that upper canal gets like a wave that goes through it, right, based on the way that that moves. Um, and then eventually it can, if it's the right sound that we can actually hear, then it has to get into this middle canal because that has the hair cells in it. And then it can eventually go out this lower canal. And then the lower canal allows the sound to exit via the round window, which is just below where the oval window is, but that goes back into the middle ear and then it can exit. But the part in the middle, the canal in the middle, is the most important part. That's called the cochlear duct. That's what has what's called the organs of Corti, also known as the spiral organs. And this is really where hearing transmission occurs. Okay, so we'll zoom in on that here in a sec. So all three of these structures we'll talk about, the cochlea, the semicircular canals, and the vestibule, they all have a special little region on the inside of them that contains the hair cells, and that's kind of the specialized place that does the actual sensation that we're talking about. Okay, so in the cochlea, this is a little bit clearer image of those canals. If we took that cochlea and unwound it and just laid it out flat, this is what it would look like. All right, so we've got the oval window right there. So the sound goes in and it vibrates the fluid here. The way this works, we have two membranes. Okay, so the membrane on the bottom of this middle canal is called the basilar membrane. Okay, so it's key to know the basilar membrane. And then the one on the top is called the tectorial membrane. And is that? Yeah, it must be on the next image. I can't actually see it there, but the one on the top here is the tectorial membrane, okay? And so really what we have is the hair cells are embedded in the bottom, okay? And they're like this, and so we have the basilar membrane down here, hair sticking up here, and they're embedded into the what's called the tectorial membrane. And so when they when the fluid inside that part vibrates, one side moves, so the basilar membrane moves, and the tectorial membrane doesn't. So tectorial membrane's totally stiff. Basilar membrane moves like this, and that's what bends those hair cells and causes the signal to be sent. The interesting part about the basilar membrane is its stiffness varies from one end to the next. Okay, so the proximal end, the end that's closest to the oval window, is the stiffest part. Okay, and then it takes the highest frequency of sound to vibrate that part. Okay, then when we get out to the end, it's gradually getting less and less stiff, so like looser. Okay, and by the time we get out to the end, it's a much lower frequency sound wave that can vibrate that. Okay, so it's all very specific. So sound is coming into our ear at all different frequencies. And so as soon as it hits the right part of the basilar membrane that's kind of coded for that frequency of sound, then it goes from that upper canal through the middle canal, activates the cochlea there, and then passes back out the lower canal and exits. Okay, but part of that sound was a lower frequency, so it doesn't vibrate the membrane till over here, right? Then goes back out, right? And so then the neurons are coded to this in a bunch of different spots, right? We have millions and millions of neurons all connecting to these different spots. So the brain knows if it gets a signal from this neuron, that's a high pitch sound, right? That's a high frequency sound. If it gets a signal from way out here, that's a much lower or deeper sound, right? And that's kind of the way that our brain is wired to receive that. Yeah, Melissa? If it'll just go to right here in the part of the membrane that it does vibrate. So like a high pitched sound will stop earlier pretty much, and it'll pass through and then exit out here. Lower pitch will make it further down here. If it's outside of the range that we can hear, then it just goes around and comes back, and it doesn't go through that middle canal, and it just exits out. Well, technically, but this is so small, right? Yeah, yeah, very, very small. Um, and the speed of sound is fast enough to have this tiny little space. But yeah, but not noticeably. Yeah. Great questions. Yeah. Other questions on this so far? Yeah.
How does that work with like going along with the
What'd you call it?
there's different brands that it like Loops is one brand
Hmm.
where you like put in ears and it helps they have different kinds for the concerts or like,
Oh, I see. Yeah. Yeah. Is it kind of like a noise canceling thing or?
it's just like a plug. So it doesn't-
Okay.
it allows you to keep conversational.
Oh, interesting. Huh. It's not electronic? Oh, interesting. Yeah. Yeah, there must be some kind of a filter in there that like somehow catches that certain frequencies of sound. What I was going to say is that with noise canceling stuff, it's different. That's actually sending a sound into your ear, right? But with that, it sounds like it's different. But yeah, I'd like to learn more about that. Send me a link to one of those. I'll check it out. Yeah, for sure. Yeah, what were you gonna say? Yeah, yeah. So if your ears are ringing, pretty much what happens is that we'll come back to this, but these are the little hair cells, right? And when they bend, that activates this cell, that activates the neuron and sends a signal up, right? And so when your ears are ringing, it's usually because you've had a really high amplitude, which is just a loud sound, and high frequency wave hit here. And since the high frequency part of your cochlea is what comes first, that usually takes the brunt of the damage with really high volume sound. And so those hair cells actually just get kind of like permanently like bent over. Right. So it kind of just like bends them over, which then activates this kind of continuously. Right. And so most of the time it's a temporary thing where you're just sending that frequency of sound. Your brain thinks you're hearing that sound all the time because those hair cells are temporarily bent over. but it can also be permanent. If you damage those hair cells completely, then they just continually send a signal to your brain. So your brain always thinks you're hearing that sound. And then that makes it so you can never hear that sound actually, right? Because you're always hearing it. So when that sound does happen, it doesn't do anything, right? So yeah, so that's called tinnitus. We'll talk more about it next time as well. But yeah, great questions. Other questions so far? Yeah, Joy. The random what? Hmm. I'm not sure about that. Yeah. Yeah. Um, yeah. Yeah, you don't know what causes it? Like it just kind of, yeah, yeah. I mean, there's definitely different causes of that. Like sometimes when you get certain types of infections, like the virus can actually get into your ear a little bit and lead to ringing. When you get certain types of like food poisoning, the cochlea is connected to nausea and vomiting too, and so certain bacteria release certain chemicals that cause that, which can also cause ringing in your ears along with the nausea and vomiting. And so, yeah, maybe it's something kind of related to that. I'm not sure, but yeah. Okay, good question. So just we'll talk about these different structures in the cochlea here. Briefly, I mentioned them, but here's the name of them. So the basilar membrane, right? That was the one on the floor of the cochlear duct. Ceiling of the scala tympani, which is just that bottom tube or that bottom canal. Okay, this is the one that does move. It's flexible. All right, closest to the oval window is the stiffest part. Furthest away is the less dense, more flexible part. And this supports the spiral organ, but also allows for that movement. So this is like the base of those hair cells. And then the tectorial membrane is the ceiling. So this is the one that's inflexible. Okay, so we need a stiff surface for the cilia to move against. Right, so if the basilar membrane and the tectorial membrane both moved equally with the vibration of sound, then the hair cells wouldn't get bent over, right? So we have to have one that doesn't move, one that does, and then that makes the hair cells bend, right? So the tectorial membrane is a stiff one. And again, those hair cells, they rest on the basilar membrane. The stereocilia are stuck in the tectorial membrane up top. Okay. All right. Next slide is labeling that. So go ahead, label that, and you can send in your answer to that question on the bottom there with your clicker. No, so the organ of Corti is the specialized region of the cochlea that has the hair cells in it. Yeah. So the cochlea is like the whole thing. Sorry. Organ of Corti is just the little part there in the center canal. And so this is zooming in on one little part of that, right?
And there's
there.
like a bunch in there. A bunch.
There would be a bunch of these. They pretty much line the whole. If you look at this one, they're lining this whole inner or that middle canal. Yeah.
That makes sense. Okay,
Yeah.
thank you.
Good question.
Wait, so is there only one organ of Corti?
No. Well, I mean, yeah, the organ of Corti is kind of the whole center part that contains all the hair cells. Yeah.
Like this, you want this.
It's just one, this is just one little section of it.
Right there.
Yeah, this is just, you're just seeing one section of it, but it does continues through the whole center canal like that. A bunch of different neurons connect to it. Yeah, it repeats. Uh-huh.
Yeah, that would have made sense if there's only like.
Yeah. Yeah. Huh?
Hair.
Yeah, it's good. All right, so you're sending in your answer there to that question. Which is the membrane that actually moves with the sound waves? Send in the letter there. All right, a few more people go ahead and send it in. And we'll go ahead and walk through this here. So you guys are pretty much split between A and B. I'll show you. Right there between A and B, okay? So go ahead and chat with the people on your team for a second. Try to convince them of your answer there, and then we'll come back together in just a sec. You can change it on your clicker if you want.
I put A, but I think it's.
I'm gonna show you. It looks like it.
All right, change it if you need to, and okay, so we got about 60% saying B, about 40% saying A. So A, what's A called? Which one is A? The tectorial membrane, right? Tectorial membrane was the stiff one that doesn't move, that the hairs are embedded in, okay? B is the basilar membrane that does move, right? So B is the right answer there, okay? So the basilar membrane is one that does move, tectorial doesn't, okay? And then we got C as the hairs themselves, the stereocilia, and then D is those hair cells. Don't worry about the difference between outer and inner hair cells for this class, but those are the hair cells. Okay. Questions on any of that? Okay, give you a sec to finish writing that down, then we'll move on to the next one. All right, so let's talk about the vestibule next. Okay, so the vestibule, again, is helping us be aware of linear movements of the head as well as the position of our head. Okay, there's a bunch of weird words with this one as well. So we have what are called the utricle and the saccule. Okay, the utricle and the saccule both contain something called a macula. Okay, so the macula is the part where the hair cells are. Okay, so just how the organ of Corti was the part where the hair cells are in the cochlea. In the vestibule, they're called macula, and there's two different ones. Okay, the reason there's two different ones is because the utricle is parallel to the base of our skull, meaning it sits like this when we're upright, and then the saccule is perpendicular to the base of our skull when our head is upright. Okay, they have a membrane that literally has little rocks in it, and that's why they're called otoliths. Okay, so the otolithic membrane with little otoliths, they're tiny little rocks that give some weight to this membrane. Okay, so it's kind of like a little jello-like membrane with rocks stuck in it. Okay, and then the bending of the cilia occurs when our heads like this, and then we tilt it back. The little rocks in there kind of pull the membrane back, and that bends the hair cells. Okay, so take a sec and label these little structures here, and you can send in the answer to that question at the bottom there with your clicker.
Is this associated with vertigo?
Typically your semicircular canals are a little bit more
Okay.
associated with vertigo, but definitely if you have a problem with these, it can lead to vertigo as well,
Okay.
for sure, yeah. Yeah. Mhm.
Yeah. Um. What's that?
Hello, you're confused?
So wait, but I just double check. Are these both otoliths?
Nope, those are the two macula,
Oh, that's the vertical and the sancule.
yeah. The otoliths are the little white rocks on top. All right, so send in your answer there. Which portion responds to vertical up and down movement? You can take a guess. Might not know the answer to that. You can kind of think about how they might work. And which ones the rocks would kind of be pulling down on as we went upwards, right? All right, a couple more people there. We're pretty spread out there, but a little bit of clumping around B and C. Okay. So yeah, so let's walk through these. So A and B are the utricle and the saccule. Okay. B is the saccule one, and so A is a little bit more like flat, right? Whereas B is like straight up and down, right? So again, if we've got one like this and the rocks are sticking up like this, the hair is sticking up like this, if we jump upwards or go up and down, it doesn't really do much, right? It can't really bend the hairs. But if we have the other one like this and the rocks are over here, right? And we go upwards, those rocks are going to kind of lag behind, right? They're going to kind of pull the hair cells down, right? So it's the one that's more upright that would respond to an up and down, a vertical movement of our head, right? And so that would be the saccule B. Okay. And we'll talk more about the function of all these next time too. So if you're not quite getting that yet, that's okay. All right, and then C. Okay. Yeah, so C is the stereocilia, those hairs again, right? D is the rocks, the otoliths. E is the otolith membrane, that like jelly-like structure that the hair cells are embedded in. And then finally, F is going to be nerve fibers from the vestibular nerve. Yeah, go ahead, Lily.
Like vertigo and stuff.
Good question. Yeah. Somebody else was asking that question too. Vertigo is typically associated with the semicircular canals, but it definitely, if you have a problem with the structure as well, it can also lead to vertigo. A lot of times vertigo, at least in aging populations, is the fluid inside your semicircular canals kind of dries up and it makes it so it doesn't flow as well. And that can kind of give you some of those symptoms. You can get vertigo from a common cold too. If the virus gets into your inner ear, it can mess with these structures a little bit. But yeah, so this one and the semicircular canals, but more likely the semicircular canals. Yeah. Okay, last one. So the semicircular canals here, they are there to help us detect change in rotation of our head. Okay, and there's three canals, like I mentioned before, for 3 dimensions. The specialized structures here, one is called the ampulla. This is just kind of the rounded base of each canal. And then the cupula is this jelly-like structure that kind of sticks up inside of that ampulla. and that's where, and the hair cells are found within that. Okay, so the bending of the cilia is produced when fluid is going around the circular part of that, and it makes the cupula bend over, and the hair cells bend with that. Okay, so we can walk through this one together here. Okay, so here's the base of one of those, of one of the semicircular canals, right? So A is the cupula, the little gelatinous part that sticks up in the middle. B are the hair cells. C, the little hairs themselves. And then D, that whole kind of bottom region of the semicircular canal is called the ampulla, the widened base. Okay, then the last slide is just a table, kind of a little recap table for you to fill in about these three different regions of the inner ear. So where is the receptor found? What kind of stimulus is it sensitive to? And then what function does that give us? Go ahead and fill that in, and we'll wrap up with that. All right, since we're just about out of time here, we can go ahead and wrap this up here. So the receptor region of the cochlea is called the organ of Corti. In the vestibule, we have macula. In the semicircular canals, it's the cupula. Okay, stimuli we're sensitive to, obviously sound here. Function is hearing. All right, vestibule stimulus sensitive to would be just position of the head as well as linear movements. And so then it's really just awareness of those things. That's the function. And then rotational movement here. Again, awareness of that rotational movement. All right, guys, we're all done. We'll see you on Wednesday. Have a good rest of your day.